Welcome everyone. Cheers for joining today's webinar. Taking some time out of your busy schedules. So today we're going to just be breaking down the new SuDS standards. They were recently updated earlier this year in the summer. So we're going to be diving into what's changed, how these changes impact you, and particularly in light of the planning developments and FRAs. So just a bit about myself and your presenters today. My name's Reese. I'm a senior flood risk consultant for FPS Environmental. I actually specialise in PFR, which is property flood resilience, but my day-to-day job does focus on FRAs for planning developments, which then subsequently feeds into SuDS designs. My colleague Alex, he's a co-presenter here. Alex will probably come on later in the session should you have any questions at the end. Alex is a civil engineer by trade. He's got 11 years experience in the development sector, and he specialises in flood risk, drainage design and development planning and highways. So quite knowledgeable. Just a bit about the company quickly before we dive into the actual content. We were founded in 2012 by Simon Carver. We specialise in consulting and engineering expertise in the flood risk sector, and we also specialise in environmental sectors as well. We're a trusted partner of the Environment Agency. We follow the Syria Code of Practice for property flood resilience. We're an ISO accredited company, so that basically ensures that all standards are delivered through every phase of the project, whatever that might be. And we're also a founding member of the International Property Flood Resilience Association, IPFA, which is quite a new development. If you've not heard of it yet, I'm sure you will hear of it in the coming years. So in terms of the agenda today, we'll initially start with the basics about SuDS for anyone who's new to SuDS, and then we'll dive into the recent policy changes. So we'll go into what it means for your projects, how to stay ahead in terms of planning developments, and then we'll finish with a bit of a SuDS in practice example of how SuDS used to be managed in terms of drainage, and how following the recent updates how SuDS should be managed. So first of all, what are SuDS? So before we start, let's just sort of get a bit of a recap as to what SuDS actually are. So SuDS are all about managing rainfall in a way that works with nature, not against it. So instead of using traditional pipes where water is discharged via the pipes and it would end up straight in the drains or sewers and rivers, SuDS are designed to sort of slow rainfall runoff down, store it, clean it. And you often use natural features like swales, ponds, and permeable surfaces to achieve that. So the idea is basically to manage water as close to the source as possible where it falls, which helps in turn reduce flooding, improve water quality, and even create more attractive and multifunctional sites. So it's not just about drainage. SuDS aren't just about drainage, they're also about making our urban environments more resilient, more sustainable, and also more enjoyable for everyday use. So that image on your left there is the 4 pillars of SuDS. And in the 4 pillars of SuDS, you have water quantity, water quality, amenity, and biodiversity. And those are I guess the core principles of SuDS, and we'll be coming into each one of those 4 cornerstones later in this webinar. So there's 7 standards to the updates, what occurred earlier in the year. So we'll be going through from standard 1 to standard 7. So standard 1 refers to the runoff destinations and managing water as a resource. So it essentially decides where runoff goes and emphasizes treating runoff as a resource, not waste. So standard 1 sort of introduces the biggest cultural shift in the SuDS standards. It no longer asks how do we get water off the site, which is what used to be the old approach, but it more asks sort of how can we best use and manage the water and runoff on the site as a resource. And in order to do that, there's a drainage hierarchy to follow. So this is called the runoff hierarchy, and it's associated with standard one. So the standard sets a strict hierarchy for where runoff should go and where it should be prioritized. So that starts with reuse. So, for example, collect for non-potable use, such as rainwater harvesting, water butts. And then the second hierarchy option is infiltration. So, can you infiltrate that water into the ground? Can you use soakaways, permeable paving? And then a third hierarchy option is discharge to a surface water body. So can you sort of channel overland flow into a swale? What can go into a pond or river? And then the fourth and fifth options of the drainage hierarchy is sewers, and last of all, combined sewers. But combined sewers are an absolute last resort. Ideally, you want to be hitting the first three options of the hierarchy, as options 4 and 5 are less desirable. So in terms of developers and designing SuDS, you must show evidence that you've explored every higher priority option before going down to a lower one. And a key point of that is money and cost can't be an option for going to a lower hierarchy option. If you need to go to a lower hierarchy option, it needs to be through detailed design outcomes and ground conditions and actual tests. So this hierarchy is essentially what planners are going to be looking for in drainage strategies. So if you can demonstrate that this logic clearly in terms of your hierarchy for discharging runoff, then you're well aligned with the updated SuDS requirements. So you'll need to show a bit of evidence and justification for your reasoning for where you're going to discharge your runoff water to. And you need to prove that you've maximised the higher priority options. So local planning authorities and lead local flood authorities will expect to see proof that you've done that. So proof means site investigations, it means infiltration tests, it means reuse feasibility studies to sort of show that you generally can't achieve a higher hierarchy option. And this all needs to be done at the outset of any design or development. It can't be done as an afterthought. So how you're going to manage your surface water and flood risk needs to be designed from the outset. So how this changes project design. The hierarchy compliance now affects all aspects of the site. It affects the site layout, it affects the materials to be used, and it even affects the building plumbing design. So early engagement is key. So for developers, you need to integrate water reuse and infiltration early in the design process. Like I just mentioned, then you need to conduct initial testing. That could be ground infiltration tests and reuse assessments. And you need to coordinate this with the landscapers and architects to fully incorporate how you're going to manage your runoff and where it's going to go into your initial design. And in terms of planners and lead local flood authorities, you will need to require hierarchy evidence before approving any drainage. So ask for justifications in terms of why the developers are wanting to manage their runoff in this way as opposed to this way. And that should all be backed up by evidence and testing. So that more or less covers standard one. Like I say, standard one is essentially the cornerstone of the new updates to the SuDS standards. So if you remember one thing, it's to document your hierarchy decisions, as that is what essentially will make or break the compliance under the new SuDS standards. So treat runoff as a resource, not waste. Follow and evidence the hierarchy. Don't rely on sewers unless absolutely necessary. And early collaboration between design and planning teams saves work. Early collaboration also saves time and it also saves cost because if you don't collaborate early on, then you're likely going to come across some rejections later on in the development, which is then going to lead to delays, resubmissions, and it's essentially going to make it more difficult to integrate SuDS into the design. So it needs to be thought about early. So we're moving on to standard two now. Standard two out of the seven standards. So essentially, we now know where water will go, which is standard one. So standard two sort of focuses on how much and how fast water should be released from your site. So standard two focuses on what we call everyday rainfall, those small, frequent rainfall events, what make up most of our annual rainfall. The aim is to make sure that the first 5 millimeters of rainfall doesn't leave the site. So in practice, that means using SuDS components like green roofs, permeable paving, swales, and even rain gardens that function to soak up, reuse that first 5 millimeters of initial rainfall, capture it on your site instead of just sending it via runoff into the drains and watercourses. So obviously you need to show a bit of compliance. Ideally, you want to look at intercepting approximately 80% of runoff from summer rainfall events and approximately 50% of runoff during winter rainfall events. So you're effectively sort of designing your site to behave more like a natural landscape for the smaller, more frequent rainfall events. And there's a few options to achieve this in terms of SuDS design. So the next few slides are basically a few options for managing runoff at your site to capture that first initial 5 millimeters of rainfall. And these next few slides sort of focus on standard one, where can we do any reuse? Can we do infiltration? Any storage or evaporation options? So one of these options is green roofs. Most green roofs are very effective at holding back the first 5 to 10 millimeters of rainfall before any runoff occurs. So that in turn slows the amount of runoff what will be dissipating into the drainage infrastructure at a given time. It sort of prolongs that, so it takes the pressure off the drainage system, reduces the risk of any sort of potential backflow occurring. Green roofs are particularly common and good for small sites with space constraints. So they're ideal for urban sites with limited ground space. They can be used in rural locations. I know in the northwest up here we do have quite a lot of motorway service stations which actually do have green roofs. Probably because it rains a lot in the northwest, but it can be a good option for urban sites. Permeable pavings, they can also be a good option to intercept and infiltrate that first initial 5 millimeters of rainfall. They're particularly good for car parks, paths, low traffic areas, particularly residential driveways. Obviously, before any infiltration or permeable paving is implemented at a site, you will need to do some initial testing just to prove that it will work with calculations. If you're situated above a clay bedrock, then clay has quite poor infiltration rates, so then you're probably not going to be wanting to do permeable pavements because it's going to have little impact on runoff. Another option is rainwater gardens and bioretention areas. These are essentially areas of vegetation. The idea is that runoff will flow into these areas. So quite often these areas need to be designed at a topographic low point, or certainly an area where runoff is going to run onto. Any runoff will get intercepted by these rainwater gardens, and they can help infiltrate water into the soil. They can also help store water on the surface as well. And a particularly good benefit of rainwater gardens is they actually treat the water and they actually purify the water just in case there's any pollutants in the water. And we're going to come on to pollutants and treating water in a little while because it forms part of the later standards. And the final option, I mean, obviously, there's more SuDS options, but we're just going into a few here. Swales. Swales are essentially shallow vegetated channels that slow water down and filter it. They're particularly good at managing the first 5 millimeters of rainfall during those high frequency, low risk rainfall events. They can absorb water and transfer it into another area, maybe a surface water body, perhaps. But you often see these in new build housing estates and by the sides of roads sometimes now. So how can developers ensure that standard two is met? I think the key principle here is again similar to standard one, and it's to plan early. Um, Developers need to integrate interception into the concept and layout stage of the design. You can't leave it to detailed design. It needs to be done early. You need to identify where the rainfall lands and how it can be managed as close to the source as possible. And you also need to design each surface at your site. So what are the roofs going to consist of? What are the roads going to consist of? What are the driveways or surfaces going to be like? Because that is such an important factor in terms of retaining and infiltrating rainfall locally within your site. And that is all what Standard 2 is about. You can also achieve standard two by using a hierarchical approach. So follow the SuDS hierarchy, similar to standard one, but focused on more smaller rainfall events. So emphasize and prioritize reuse, collect rainwater, store it, infiltrate uh, the runoff, so you can mimic natural infiltration. You also need to demonstrate compliance to meet standard two. So, compliance refers to ensuring that 80% interception of service of runoff during summer storms and 50% interception during winter storms. And that can be all calibrated through modeling and simple calculations in your SuDS designs. And it likely requires, detailed drainage design to be submitted as part of the application. But also, follow local authority guidance. Obviously, these are national standards, so it's important to follow these. But depending on who your local planning authority is, it's important to refer to their local websites and their local guidelines. Some of that information might be in their SFRA document or their Surface Water Management Plan. So it's important to look at those because they might have some different priorities, especially some of the London boroughs. And this is probably one of the most important ones, combined features. SuDS aren't just a one component fits all solution. In order to work effectively, SuDS need like a range of SuDS needs to be implemented at a site. And if you implement a range of SuDS, then it's likely going to work more efficiently. It's going to intercept rainfall better, and it's going to meet standard two by intercepting that first 5 millimeters of rainfall more adequately. And it also ties into standard three quite nicely, which we're just coming on to now. So standard three refers to the management of extreme rainfall and flooding. So standard three deals with what happens when it really rains. Those big storm events, what can cause flooding if we don't design carefully. So where standard two was about the high frequency, low severity rainfall events, standard three is about the less extreme rainfall events, but those rainfall events what can cause big problems because they're quite serious in nature. So standard three requires a SuDS-led approach even for extreme rainfall. So rather than relying on a single big tank at the end of the system, like traditional drainage methods would, we need to now design a network of features that work together to store water throughout the site. So the aim of Standard 3 is essentially twofold. You need to protect the people and the property within the development itself, but also make sure that the development doesn't make flooding worse downstream. And to achieve that, the runoff rates need to be controlled to no more than greenfield runoff rates. And greenfield runoff rates are 3 litres per second of water per hectare. So you need to essentially treat your site's runoff as an empty field with the greenfield runoff rates, which is 3 litres of water per second per hectare. Now, obviously, some sites are urban, you have brownfield sites, and it might not be adequate or feasible or able to get your runoff down to greenfield runoff rates. So the new standard does allow some flexibility in that for achieving greenfield rates if it's not possible, but essentially you still need to demonstrate that you've minimized flood risk at your site. And you also sort of need to account for climate change as part of your design to address standard 3. So it's advisable to use the upper end allowance for climate change to reflect the lifetime of the development. And you also need to include a 10% urban creep, which I'll come on to on the next slide. But this emphasizes that it's good practice to have multiple points of storage, using swales, basins, rain gardens across the development, spread storage and slows the flow. Everything must be backed up by modelling in your design to achieve standard 3. But yeah, in summary, standard 3 is all about designing for resilience, to make sure that we're prepared for the climate change, strong storm events. So how can developers achieve standard 3? Well, to achieve standard 3, it means planning your resilience from the start. Again, planning early is key for standard 3, and it's a common theme across all the standards of what we're going to go into. You need to plan early, and if you don't plan early, you're probably going to run into some difficulties. So you need to control your discharge. You need to spread your storage of water across your site and improve your design. Standard 3 isn't just a tick box exercise. It's generally about ensuring that in the 1 in 100 year storm, your development still functions as it would on any given day. And it also ensures that the wider community downstream is protected. So this can be achieved using multiple SuDS features, and it can be achieved by applying the latest climate change uplifts. We typically are advised to use the upper end allowance for climate change, which covers the design life of the development. And you also need to include the 10% additional impermeable area, which accounts for urban creep, which is additional impermeable surfaces. So that image on your right-hand side there, you've got the same image, one's from the 1990s, and another one from 2005, another one from 2015. So you can see in the 1990, the only areas of impermeable surfaces are the houses themselves and the roads. You've got quite a lot of green space there, green vegetated areas, which is the garden. Fast forward to 2005, there's a slight change in appearance. One or two houses there seem to have had an extension done, or they've had some patio paving put down in their garden. And if you fast forward to 2015, it looks quite different. There's a lot more paving areas, there's a lot more extensions, and essentially that initial area of green space has reduced quite significantly. So what that in turn is going to result in, it's going to result in less infiltration during rainfall events, and it's going to increase the amount of surface water runoff, what is discharging onto adjacent areas. And the new standards have implemented this 10% urban creep, but you need to account for it because of climate change. We're now seeing more extreme rainfall events. They're becoming more frequent and more intense. Traditional drainage systems such as pipes and sewers are no longer designed to account for these extreme rainfall events, what are becoming quite common. So the new standard, particularly standard three, reflects this shift in weather patterns and more extreme events, and that's why we now need to account for it. So we're now moving on to standard four, towards the back end of the standards. So standard four now sort of shifts our focus from quantity in terms of volume of water to quality. So how can we protect rivers? How can we protect our groundwater from pollution runoff, essentially? So the gist of Standard 4 is that, cars and other commercial users create dirt, they create contamination, and they create pollutants which accumulate on the ground surface. And when it rains, these accumulated pollutants can run off with the rainwater and essentially pollute downstream areas, that they can pollute rivers, and they can be really quite toxic for fragile ecosystems. So we kind of need to capture these pollutants and clean the water from our site before it's discharged. So to meet the standard, designs like SuDS designs, they must follow the SuDS management train and show evidence of multiple stages of treatment. So to do that, you have source controls, you have site controls, and regional controls. So source controls can be features like swales, basins, forebays, and permeable paving. These can intercept rainfall runoff as close to the source as possible on your site. And then you have site controls where if you do have any water or rainfall what falls on your site and begins to run off via overland flow, where's that water going to go? Can you design your site to channel that runoff to a particular area? Can you channel it to a swale, or can you channel it to a filter strip? Filter strips are quite common for car parks, which are quite bad for pollutants on the surface. And these features will essentially not only slow the rate of runoff, but they'll also filter it. They'll purify it. They'll trap finer particles, and they'll remove the majority of the contaminants. And then you have regional controls like detention basins and wetlands, but they're more of like a wider catchment sort of thing. So yeah, in short, Standard 4 sort of moves us away from simply containing the runoff to cleansing it. The goal is to sort of ensure that the water leaving the site is actually cleaner than what used to run off before the development. So this helps meet water framework and biodiversity objectives. So we now come on to Standard 5, which is amenity. Standard 5 focuses on the human and environmental amenity benefits what SuDS can bring. So SuDS go beyond what is just drainage. They can also be used as, a nice space. The key is sort of, multifunctionality. So SuDS should manage water, but they should also create a pleasant, usable public space for people, and enhance the landscape and character. So for example, you could have a rainwater garden at a commercial site. You can, instead of just having it as a rainwater garden to manage runoff, you could incorporate paths. You can have some benches, some picnic areas, so it can be used as a functional site for people. So yeah, standard six now. Standard six just refers to the biodiversity benefits what SuDS can bring, and this is heavily emphasized in the updates. So you need to document how your SuDS scheme will enhance biodiversity and increase habitat diversity, as well as contributing to the local and benefits of SuDS. So Standard 6 ensures that SuDS isn't just about managing water, it's also about enhancing biodiversity throughout the site's life cycle. So again, early planning is key. You will likely need an ecology study, because it's all well and good implementing a rainwater garden and implementing plants and vegetation, but are they the correct plants and vegetation. It needs to be specific to your site. Some plants like a naturally wet ground, whereas others don't. And it's important to implement the right type of vegetation to support the local biodiversity as part of your SuDS scheme. So, think ponds, think wetlands, swales and vegetated features that, double up as habitat corridors. And as I just mentioned there, early in the project, you probably need to conduct a biodiversity risk and opportunity assessment and consider the specific flora and fauna suitable to your site. And that brings us on to our last standard now, which is Standard 7, which refers to the drainage design and life cycle management. So Standard 7 essentially emphasizes that SuDS should be practical to build and easy to operate once installed. So the designers must consider the construction sequencing, access for machinery, and site conditions. It's all well and good having this idea of a SuD, of a SuD scheme for your development, but is it easy or is it achievable to even design? And again, that's why early planning is key. Um, Standard 7 also says that every SuD system needs a lifetime management plan. So a lifetime management plan essentially covers aspects such as routine maintenance, like sediment removal, vegetation management, and general inspection and upkeeps. It outlines the responsibilities of the owners, the residents, or the management companies. It needs to outline their responsibilities in managing the SuDS features. So that ensures, record keeping to demonstrate compliance with standards. And essentially, Standard 7 is basically to ensure that whatever SuDS are implemented, they're managed and maintained over time so that they continue to deliver flood control, water quality, and biodiversity and amenity benefits. If a SuD's neglected, then it's not going to function to its potential. It's going to struggle to intercept the first 5 mil of rainfall. It's going to struggle to deal with the big 1 in 100-year storm events. So Standard 7 ensures that SuDs are maintained accordingly over their lifetime. And this all needs to be documented through the planning process. There's like an interesting point at the end of the screen there, which reads that Standard 7 is not standalone. It ensures the goals of standards 1 to 6 are maintained over time. So it certainly feeds into the other standards. If you nail the other standards and comply with them, Standard 7 just ensures that it will be maintained once it's installed. So very important. And again, that just brings us back to the 4 pillars of SuDS. Obviously, water quantity refers to Standard 1 and Standard 2. Water quality there, how can you make sure that the pollutants and the water runoff is pure, it's not contaminated. Amenity, how can you design your SuD as a functional, practical space? And again, biodiversity, how can you ensure that the SuDS features enhance the local wildlife ecology? And just to finish off before we get into any questions you might have, there's the slide here what essentially says SuDS in practice. So you've got 2 images on the screen there. The left-hand image is typically how rainwater runoff used to be dealt with. So rain would fall, it would run off the buildings, it would run off the roofs, it would run off the gardens, run off the driveway areas, and it would usually just get discharged and end up in some sort of drainage pipe. It would end up in the sort of pipe network. It might have gone into an attenuation tank, and after that, it would have just ended up discharging into the local sewer network or a watercourse in some cases. So this would have put immense pressure on the drainage infrastructure. There's nothing to slow down the rate of runoff. There's nothing to store it, infiltrate it, or hold it. So this is why so many people in the past have unfortunately experienced flooding, particularly surface water flooding. Whereas you move over to the right-hand side image, which reflects the approaches in the new standards updates. So you have a range of SuDS features. You have green roofs, you have permeable paving, you have a swale there, and you have surface water bodies which can hold water. So all of these features combined essentially slow the runoff rates, and they help just protect homes and communities from essentially flooding. And that's what the SuD standards are going to try and implement at a national level going forward. So yeah, cheers for listening to that. You've done well if you're still awake, listening to me talk. But yeah, if you've got any questions, we will have a bit of a Q&A now with myself and my colleague Alex. So yeah, please ask any questions and we can answer them as best as we can. There is a QR code there, which I think takes you to the company website if you're interested in anything else as well. Yeah, cheers.
Thank you so much, Reese. That was really insightful. And I think you are quite a calming voice to listen to as well. So someone did ask if the slides will be shared. You'll get a recording of this webinar after the session is finished, and then that will give you access to the slides. If you would like the slides sent in over separately, then just drop us an email at inquiries@fpsenvironmental.co.uk. You see that question there, Reese, from Rachel?
Sorry, I might need to stop sharing my screen to read the question.
It says, please can you advise on timescales for introduction application of the new standards?
Introductions to timescales. I think from my understanding, the updates are already in place at a national level. So I think every planning application going forward, you will need to show that you've incorporated and addressed the new updates to the standards, particularly with FRAs and planning developments. Every FRA now and every development now needs to consider drainage. So you need to show as part of your proposals where you're going to discharge your runoff to and how you're going to do it. So I think I'm pretty sure it's already in place. I'm sure my colleague Alex will back me up on that, but you should be addressing it now, essentially, or else you're going to lead and result in rejections and delayed applications because you haven't met the new standards to how you're going to address your runoff. So it's good to get the ball rolling and address it now.
Alex, do you have anything to add to that?
Yeah, second reach really. Yeah, so effective immediately, really, and it's more of a question of, you know, from rather than the developer side, it's more the local authority in terms of how they want to test new sites coming forward and if they're meeting those standards, really. So there'll be a bit of a grey area as we currently are in terms of how developers adopt the standards and implement them in current proposals, and then it's also once schemes are submitted through planning, it's how councils might interpret those standards. Probably in a bit of a grey area in the middle at the moment, but moving forward, yeah, this should be the approach for all developments, small and large. So it's appreciating water, managing it naturally is probably the big takeaway. Yeah, effective from now. Yeah.
Yeah, Rachel's also asked if there's any advice over transitional arrangements for applications already in train.
I think that's a case-by-case basis, really. It's obviously, these came out earlier in the year, so there has been a bit of time in terms of transition. It will be yeah, it depends on what authorities assessing it, and the sort of particular constraints and opportunities on those sites. So it's yeah, it's really is on an individual basis, and if you can incorporate this best practice, then it's obviously that's the way to go. If there's tricky sites, there's more constraints, more brownfield sites, it's that conversation to have with that local authority, who are essentially going to be the deciding factor, whether you meet that criteria or if there's a bit of leeway in terms of using some older standards or not in the current. But that's a conversation to have direct on specific sites.
Okay, we don't have any other questions at the moment. I'll just give everyone just a few seconds if there is anything that crops up. But we'd just like to say thank you, Therese, for putting that together for us. We will
At
be
any time, yeah.
we will be attending FloodX on the 26th, 27th of November at Excel. If anyone is attending there, we will send out an email about that so we can hopefully meet some of you face to face. But I think that's all for questions. So I'll end the event now. But thank you all for taking the time for coming today.
Yeah, cheers, everyone. Appreciate it.
Okay, have a good rest of the day, everyone.